So first of all, we'll go to dinitrogen. Generally, we do not call it dinitrogen. We call it nitrogen. But why should you say dinitrogen? Simple reason is that the symbol of nitrogen is N, but the molecule of nitrogen contains two nitrogen. Because of that, we call it dinitrogen. Just to differentiate between nitrogen molecule and nitrogen atom. You know that this is one of the abundant element which is freely available in the nature. We get nitrogen in the around 76% of our atmosphere consists nitrogen. It is the uncombined state or free state or native state. And nitrogen you can get it in the both in the living and the non-living systems. Living systems means plants and animals. Nitrogen is the major ingredient of proteins. Protein are made of alpha amino acids. Amino acids contain nitrogen. So it is abundantly found in the living system. And in the non-living system, you can get nitrogen in the form of nitrates, nitrites. You know that plants survive on nitrogen. The one of the most essential element which is required for the growth of plants is nitrogen. And these plants inherit this nitrogen from the soil, from the form of in the plants in the soil we get a lot of nitrates and nitrites. And plants in the roots, they have nitrifying bacteria. They convert nitrogen, nitrite and nitrates into nitrogen. All right. So let us go directly into its preparation. Preparation again, we can classify into two categories. Is a laboratory preparation, and second one is the industrial or commercial preparation. See, nitrogen can be obtained by simply by heating ammonium nitrite. But ammonium nitrite, we never should heat in the dry or solid condition because it explodes. Okay, this ammonium nitrite is being used for IED blast, improvised explosive devices. So almost throughout the world, the now solid nitrite, especially sodium nitrite or ammonium nitrite is not sold. So what do? We take a solution of sodium nitrite and mix it with, I write here F1, and we mix it with ammonium chloride 1:1 ratio, and we heat it. So once you heat, then you get here sodium chloride and ammonium nitrite, both in the aqueous medium. In aqueous medium, if we heat, it does not explode. So now ammonium nitrite, if you heat it, it decomposes to give us nitrogen and 2H2O. So I'll write here. So what should I write now? See, these are the partial equations. Huh? So you'll find this and this will get cancelled. So I can directly write here sodium nitrite aqueous ammonium chloride aqueous. You'll get here sodium chloride aqueous 2H2O, and here I'll write now H2. Right, very fast. This very big chapter. Okay, so this is one. Now it also can be nitrogen also can be obtained by decomposition of ammonium dichromate or metal azides. So I'll write now here. Ammonium dichromate is a very interesting thing. You or might have seen some in science exhibition. This is orange in color. Okay, and if you heat it, you'll find lot of fire and fume is coming out, huh? Because and ultimately you will get a green mass, and you will get here it is going to evolve nitrogen gas. So I don't know, in exhibition you might have seen artificial volcano. Artificial volcano is being made by heating ammonium dichromate. Okay. Pure nitrogen can be obtained by heating metal nitrides like sorry, I made a mistake. A metal, not nitride, azides. Sorry. Azides like what mistake I'm making today. I think I'm getting a little exhausted. So many classes I've taken. Na, N3 and barium. So if you have heated, both these reactions are important because of their decomposition nature. So you get now here sodium metal and nitrogen. Or if you have taken barium azide, you get here barium and the this P-block note, I think this one, I have to scan it and I'll send it. It will take around 2-3 weeks because I have to give it to Somnath and it is a lot of work also. So whenever he will find time, he will do it. Third, nitrogen can be produced by oxidation of ammonia by copper oxide. by red hot copper oxide. Okay. Or by chlorine. So now if you write here now NH3 CuO, you get here now copper CH2O. It can be also oxidized by chlorine to give you HCl. Okay, now manufacture. We require huge amount of nitrogen is required for two reasons. One, in the packaging industries. All the food products which generally can get spoiled by the aerial oxidation by the microorganisms are all being packed under nitrogen. All the food products that you use, different types of chips and all these things are always being packed under nitrogen. So huge amount of nitrogen is required for packaging. And second, nitrogen is used in chemical industry to maintain inert atmosphere. All right. And second, in different industrial preparation like ammonia is being used from nitrogen only. Just a minute. Class. Okay. Now in this manufacture nitrogen, we can get it from very cheap source. Okay. So commercially nitrogen is obtained by fractional distillation of liquid air. This is very cheap method. So we liquefy air. We cool and put lot of pressure in the air. So in that case, the air becomes liquid, just like water. And from there, the nitrogen is being because nitrogen has the largest concentration, and so in that case, you'll find the nitrogen will come out from there. It is being distilled under very low temperature, so you can get nitrogen, and rest will be containing oxygen. From there, second fraction you can get oxygen. Oxygen is also will separate by the fractional distillation of liquid air. So now we'll go for its physical properties. So physical property, what I can say? I know, right? Anything physical property, you know that nitrogen is a colorless gas. It doesn't have any taste, and it is practically almost insoluble in water. So these are the physical property of nitrogen. So let me go to the chemical properties. First, let me write here. Abnormal behavior of nitrogen. See, we have already read about the group discussion. So the elements in that fall in the group, they are supposed to behave almost same. Physical properties will differ. Physical property depends upon their atomic sizes or mass, intermolecular forces of attraction. So that is going to be differ, but they are supposed to show us the same chemical properties. Why same chemical properties? Because all of them have the same electronic configuration. But we find nitrogen does not behave like the rest of the elements in this group. So this is important for exam. Okay. So nitrogen does not behave like rest of the elements of group. Not only applicable for nitrogen, first member of each group in P block. Not only each, almost all the elements, group 1, group 2, then you go to P block, they do not behave like the other elements. Why? Is due to the following reasons. Okay. 1. Small size of nitrogen. As the size is small, the atomic radius is small. Okay. And if the atomic radius is small, they have very high ionization enthalpy. They have large negative electron gain enthalpy. They have very high electronegativity, and moreover, it does not have any d orbital. So let me write one by one. Second, very large ionization enthalpy more negative electron gain, enthalpy high electro negativity and high absence of that I told you d orbitals in their valence shell. What is the electronic configuration? See here is 1s2, 2s2, 2p3. It does not have any d orbitals. And having high tendency to form p pi bond. Please write down.
Done, sir.
So this is important for exam. So now we'll go for see. Under ordinary condition. Under ordinary condition, nitrogen is chemically inert. Inert means it does not. Why? This is because of its very high bond dissociation enthalpy due to the presence of nitrogen triple bond. See there, because any element, if you molecule, if you react, first it has to break into an atom. John Dalton has mentioned more than 200 years back, without any knowledge of the machines that elements combine always in the form of atom. It's perfectly correct. Because if the nitrogen has to combine, all the three bonds has to be broken, and it requires very high amount of energy. Okay, so it is a blessing in disguise for us. In atmosphere, we have 76% nitrogen and 20% oxygen. If the nitrogen would have been highly reactive, it would have reacted with oxygen, and we would not have any oxygen in the atmosphere to breathe. Then this you will find both the plants and animals would not have been existing in the surface of the earth. So, due to the presence of nitrogen triple bond. However, it reacts at high temperature and also in presence of water. You know that when nitrogen reacts with oxygen and it forms oxides of nitrogen in the atmosphere only when there is lightning. Each lightning creates 3000 degrees Celsius, you cannot imagine, or 3273 Kelvin. And now you understood whenever there is lightning, why the people die, animal dies. Sometimes you will find it catches fire. Even they uproot the trees because of that high temperature. Okay. So now we'll write here. I'll write some of the reactions, maybe little not there in the book. First we'll write here. Reaction with metals. Always remember, these are always high temperature. Okay, so it reacts with lithium. I'll put here delta. It is LiPn2. These are called nitride. This I would already have shown you when I have discussed the one for the group discussion. Lithium nitride. All elements do not form nitrates. From alkali metals, only lithium forms. Sodium, potassium, they do not form. Group 2 metals, they react. This is for entrance exam, tell you from first group only lithium reacts. So magnesium reacts with nitrogen to give you Mg3N2. So I have made a mistake here. It should be balanced. It should be like this. Okay, 2 and 2, so it will be like this. I made a mistake. Okay, it's called magnesium nitride. Aluminium, both of them have the valency of 3, so no problem. So it will give you Al. Is aluminium nitride. So this is not in the book, no problem. I will not give so much extra to you. Whatever I feel that necessary can be asked. So this is reaction with metals. Now reaction with non-metals. Reaction with non-metals. Okay. This is a very famous equation, you know. This is called Haber's process of manufacture of ammonia. In this case, it is reacted at 407. Sorry, not 400. It is temperature is 725. Yes, 725 Kelvin and 200 atmosphere in presence of iron as a catalyst and molybdenum as a activity. So it will give you 2. that we are going to study just after this. This is called Haber's process of manufacture. Now,
Excuse me, sir.
yes, yes.
Sir, how much atmosphere is that? I cannot.
I could not understand. Your voice is cracking.
Sir, how much atmosphere is that? After
200,
725
200
Kelvin.
atmosphere. 200 atmosphere. Nitrogen and
Sir,
oxygen.
after 725 Kelvin, how much atmosphere?
200.
Okay, thank you, sir.
Nitrogen and oxygen combined in presence of 300 to 73 Kelvin or lightning. To give you to nitric oxide. Okay. Okay. Now nitrogen combines with calcium carbide in presence of nitrogen at high temperature to form. I'm just writing this one. Okay. We call it calcium. This is only for your entrance. Calcium cyanamide. Okay, plus carbon goes out. This is also called nitroline. This is used as a fertilizer. Fertilizer. Because moment it comes in contact with calcium cyanamide, when it comes in contact with the water, it forms ammonia. Moment you finish, you tell me.
Done, sir. Done, sir.
Okay. So now I'll go to the compound of nitrogen. So in the compound of nitrogen, first we come across okay. So we'll go for first we'll go for laboratory preparation, followed by industrial. So this laboratory any ammonium salt except ammonium nitrite and ammonium nitrate. Why? Because they are explosive in nature. When treated with base, produce ammonia. Say I have taken ammonium sulfate and I have treated with sodium hydroxide or potassium hydroxide. We generally go for sodium hydroxide, is cheaper. So it will give you sodium sulfate, water, and ammonia. Let me balance this one. Sulfate is 2, so I have to write here 2. Okay, 2 ammonia, 2 and 2. So this is, it will come out in the form of gas. If you have taken ammonium chloride solid, okay, and if you have taken here calcium oxide lime, mix it thoroughly and you heat it, it will give you calcium chloride, water, and ammonia. This is the actual laboratory preparation of ammonia. We generally don't prepare by this method because ammonia is highly soluble in water. As you have taken aqueous solution, in that case, what will happen? Most of the ammonia will be dissolved in water. So it will be utter a loss for us. These are all solid. Water which will be produced will be absorbed by calcium oxide. Now, if you want to dry ammonia, we pass this calcium ammonia through calcium oxide. Through dry ammonia, it is passed through quicklime. I have written intentionally for your entrance. Quicklime is called calcium oxide. Calcium hydroxide is called select lime. Calcium oxide is called lime. And calcium carbonate is called limestone. Okay, quicklime. And not through concentrated H2SO4 or phosphorus pentoxide. Yes, they react with ammonia. Please remember for your exam. So we never pass through sulfuric acid and phosphorus pentoxide. Sulfuric acid and phosphorus pentoxide is very strong dehydrating agent, but we never, because ammonia will react with, moment you pass ammonia, ammonia will react with sulfuric acid to give you ammonium sulfate. If it pass through phosphorus pentoxide, it will give you ammonium phosphate. Okay, so we never pass through that. Go to the proper light. বসা
Done, sir.
Okay, good. This is one, it is two. First one is one. Ammonia can also be generated by addition of water to metal nitride. Just now you prepared nitrides. So if you have added water drop by drop to calcium nitride or any other nitride you have, it will give you it will immediately liberate
Done, sir.
Okay. Now we'll go for is manufacture. Manufacture or industrial production. Okay, this is called Hubbard's process. Ammonia is prepared commercially by Hubbard's process. In this case, a mixture of pure and dry nitrogen and hydrogen gases are passed over iron catalyst in presence of molybdenum as promoter. At 725 Kelvin and 200 atmosphere. So N2 plus 3 N2G this is a reversible reaction. 725 Kelvin, 200 atmosphere, iron as catalyst, and molybdenum as promoter. Okay, so it gives you this. Enthalpy of the reaction is exothermic 93.6 kilojoule mole inverse.
Done, sir.
Okay. Now, ammonia we require huge amount of ammonia we require in the preparation of urea as a synthetic fertilizer. Not only that, other than that also ammonia has large scale use in industries. So we should see that how can you improve the yield of ammonia because it is a reversible reaction. In reversible reaction, what will happen? Say one molecule by this time, this molecule react to give you ammonia. By the time second batch starts forming, this decomposes to give you ammonia back. So in that case, maximum yield of ammonia we can get is 50%. 50% will be again gaseous. So how to improve the yield of ammonia? So improvement of the yield of ammonia. First of all, we'll again write this equation, and from this equation only we'll try to find out our answer. Write this equation, then after that I'll explain one by one. Okay, now see the conditions. What are the conditions? Let us try to know one by one. See, this is a reversible reaction and it is exothermic in nature. So in that case, in class 11, that in equilibrium chapter, that is a portion called Lee-Chatelier's principle. Lee-Chatelier's principle says, if you want to shift this one to, if you want to shift it to more to the right hand side, means you want to add more product, then you have to see some conditions. What is this? See, this reaction is exothermic. So Lee Chatterley has mentioned that if a reaction is exothermic and already is producing heat, and to that if you supply more heat here, this molecule will break faster. So what you have to do? In that case, you have to carry out this reaction at lower temperature. Okay. The yield of ammonia can be increased by following Lee-Chatelier's principle. So what is this? First we'll see effect of yield. So what we'll write now? This reaction is exothermic. So to push the equilibrium, no, I'll just change little bit here, huh? Okay, here I'll write. This reaction is reversible because Lee-Chatterley's principle is applicable only for reversible reaction. This reaction is exothermic, so to push the equilibrium, what is the equilibrium? That is, we want more product. So in that case, what will happen? See, if you want to push the equilibrium now, you will find in that case, it will be like this. There will be more product and less reactants. This is the meaning of this. To push the equilibrium towards right, right now, that is more ammonia. The reaction has to be carried out at low temperature. Now see here. In that case, you can say, sir, we'll carry out at room temperature. But we know at room temperature nitrogen does not react. You have to supply an optimum temperature by which the nitrogen triple bond should break. Below that, if you keep, nitrogen will not react. So, what should you write? Hence, an optimum temperature of 725 Kelvin is maintained. This is very important for your school and board exam. Done.
Yes, sir.
Okay. Now see another thing. See, this is a gaseous reaction. Here, see, you have taken here 1 volume. Here you have taken 3 volume. How much you got? 2 volume. So the volume of the product is found to be less than that of the volume of the reactants. In such cases, if you wish this equilibrium should shift towards the right hand side, you have to carry out this reaction under high pressure. So effect of pressure. This reaction leads to the decrease in volume of the product. And to shift the equilibrium, towards right, it must be carried out under high pressure. So a pressure of 200 to 1000 atmosphere is maintained.
Done, sir.
Effect of catalyst. In order to obtain better yield of ammonia, the reaction is carried out in presence of iron as catalyst and molybdenum as promoter. So these are the three conditions. In exam, they'll ask you, please write. I have written in the simplest possible and short possible way of writing.
Done, sir.
Okay, now we'll go for properties. Physical. Physical properties. ঠান্ডা নেই বাবা, ঠান্ডা জল গরম করছে না তো, বুঝো ঠান্ডা জল খাই যাও। কি করতে হবে? It is a colorless gas with strong pungent odor. It is highly soluble in water as it undergoes association with no, as it undergoes intermolecular hydrogen bonding with water molecules. So I can show you that this is ammonia. See, this is the lone pair. So this will bind to. So each molecule binds with 4 molecules of water. Okay. Chemical properties. See here. Association with water. It reacts with water. Ammonia reacts with water to form ammonium hydroxide. Second, basic character. Ammonia, see, the lone pair, is a loose base. And it reacts with acids to form corresponding salts. Okay, suppose you have taken ammonia. So if you have taken HCl, it will form ammonia. If you have taken ammonia, sulfuric acid, it will form ammonia. Let us come for organic acid. Suppose you have taken here acetic acid, it will form CH3, COO, and HO. Carbo. This is called ammonium acetate. Formation, this will not, now what I am writing, you may not understand, we will understand after, say, 1.5 months. Formation of complexes. Ammonia is a strong ligand. This one you understand when you go to coordination chemistry, strong ligand. And form varieties of complex or coordination. It's called coordination. Write the reaction on the top. Both the reactions are very important for your exam. If you have taken here silver chloride, yeah, silver chloride is insoluble. Insoluble. Why? If you added here excess of ammonia, immediately you will find the white precipitate dissolves. Okay. Now, why does it dissolve? That I you get this. This is called di. See, it's double M. Diamine silver. This is Roman 1. Gap. So what will say? Dissolves in ammonia. This question comes. What happens when ammonia is added to white precipitate or silver chloride? You simply say on addition of ammonia, the white precipitate dissolves due to the formation of this compound. Or if you do forget also the name of the compound, if you forget the formula also, if you simply write the white precipitate dissolves in ammonia, you'll get full marks. I'm giving you all these things so that nobody should tell that you do not know chemistry. I should be proud of you. Then, in your book, they have given copper ion. So I'll also write the same way. Suppose you add ammonia to copper sulfate is pale blue there. Moment you add ammonia, it forms a deep blue, just like ink, it forms a solution. Okay. I'll write now here copper 2 ions. And if you have added ammonia here, because in school they follow the same thing as your book. So if I write the full formula, your miss or sir may not be happy. So you'll get now here. I will now here pale blue. And here I'll write the name of it. It's called tetraamine copper 2 ion. 2 plus. Deep blue solution.
Done, sir.
Very good. Now, reaction with metal salts. Various metal salts produce corresponding metal hydroxide on reaction with aqueous solution of, what is aqueous solution of ammonia? You should not get scared. It is ammonium. Okay, so I can write here ferric chloride 3NH4OH. This is yellow solution. I'll write here now aqueous. It will give you ferric hydroxide solid precipitate. Okay, and you will get here 3NH4Cl. This is soluble water. This is chocolate brown precipitate. When you do practical, you will find it is there. Chocolate brown precipitate. Okay. If you add it to aluminum chloride, CnH4OH, you will get here now aluminum hydroxide 3NH4Cl aqueous. This is F. This is called silky white precipitate. Okay, okay, this two is enough.
Answer.
Reaction with chlorine. This is again very important. Reaction with chlorine. A. With excess of chlorine. NH3 plus 3Cl2. It will give you NCl3 and 3HCl. Why do you call it excess chlorine? See, it is 1:3. This is called nitrogen trichloride for entrance. Explosive in nature. Why it explosive in nature? Because it is unstable. Okay. B. With excess of, here I'll do it in 2 steps. In your book, only 1 step is given. Because of that, you have to by heart it. Now you'll understand, then you will not by heart. 2NH3 CCl2. It gives you nitrogen and 6. Now try to understand. This is basic and this is acidic. What will happen? This HCl will react with the rest of the amount of ammonia. So now we know NH3 plus HCl gives us salt. Just now we have done ammonium chloride. Ammonium. Now dear, how many are there? 6 now. I have to multiply by 6. I have to balance it. 6. Okay. So this and this get cancelled. Now see here. 2 plus 6, 8. 8 NH3. 3Cl2. It will give you 6 NH for this plus. Both the reactions are important. Now see, very interesting. Removal of hydrogen is oxidation. Chlorine is doing oxidation. Here, chlorine is doing complete oxidation. All hydrogen is removed. And here, chlorine is doing partial oxidation. See, hydrogen is removed, but still some chlorine is there.
Done, sir.
Okay. All right. Now, the thing which is not given in your book is called reaction with metals. Ammonia reacts with group 1 and 2 metals at room temperature to produce an intense blue solution. Okay, at low temperature. This is because it contains ammoniated electrons, ammoniated free electrons. This reaction, this solution is paramagnetic and conduct electricity due to the presence of free electron. So this one you have studied in class 11, but you forgot. Suppose I have taken here sodium. You can take sodium, you can take lithium, you can take magnesium. See what happens? This sodium is ionization enthalpy of sodium is very, very low. So immediately is going to lose electron. So this is cation and this is anion, they are not stable. So what happens now here? Immediately you find ammonia molecule is going to surround them. So I write now here NH3X NH3. So anything surrounded by water, we call it hydrated. Anything surrounded by ammonia is called ammoniated. So this solution is blue because of this electron. For this solution is extremely reducing in character and is used for the reduction of organic compounds. This is only for your entrance I have given. Okay, so that is known as, this reduction is known as Birch reduction. It's not Birch. It's a very fast reduction.
Done, sir.
Okay. When ammonia gas is passed over hot alkali or alkaline earth metals, means what? Group 1 and group 2 form corresponding amides. Say I have taken here sodium and ammonia. Okay. You get here now Na, NH2. These amides are very strong bases. I'll take 2-3 minutes more, I'll finish.
Done, sir.
Okay. So now we'll write with reaction with Nessler's reagent. So what is Nessler's reagent? It is K2 AgI in presence of potassium hydroxide. It is Nessler's. When ammonia is heated with Nessler's reagent, brown precipitate called iodide of million basis of K2 Ag. Right? So you'll get now here 7Ki 2H2O plus HgIO Hg NH. This is called Milan state. So with this, I finish ammonia.
Done, sir.
Okay, then good night.